Welcome, everyone, to this explainer. If you've spent even 5 minutes on a factory floor, you've definitely run into this massive ongoing debate. It causes endless confusion among engineers, technicians, and plant managers. I'm talking about the heavyweight showdown of motor control, the soft starter versus the variable frequency drive, or VFD. Well, today, we are clearing the air entirely. We're going to break down exactly how these technologies work, where they shine, and how you can make the absolute best choice for your specific industrial applications. Let's get into it. Okay, let's dive into exactly what we're going to cover today. First, the motor control dilemma, then components and working principles, followed by the ultimate comparison. After that, we'll hit the applications and selection guide, common mistakes in safety, and finally, wrap things up with DEVI automation solutions. Section 1. The Motor Control Dilemma. Walk onto literally any shop floor, and you're going to hear these exact same pain point questions. Do I need a soft starter or a VFD? Which one is actually going to save me more power? Which one protects my incredibly expensive motors best? We all know the daily struggles of starting heavy machinery, right? Those sudden, massive spikes in starting current that can practically dim the lights across your whole factory, and that violent mechanical stress that just eats belts, gears, and bearings for breakfast. Solving these problems isn't just nice to have, it's absolutely crucial for your bottom line. Moving on to Section 2, Components and Working Principles. Let's look under the hood. First up is the soft starter. Think of this as a device that intentionally and temporarily holds back the electrical voltage during a motor's startup phase. By doing this, it provides a really nice smooth ramp-up, which significantly cuts down on both mechanical wear and electrical stress. Now, the core components pulling this off are the SCRs, or thyristors, which act kind of like electronic valves for the voltage. You've also got a heatsink to manage temperatures and a bypass contactor. But, and this is a vital detail to remember, once the motor is fully up and running, a soft starter runs it at a fixed, constant speed. Now contrast that with the VFD. This thing is fascinating. A variable frequency drive doesn't just manage the startup, it's a complete controller that drives an electric motor by varying both the frequency and the voltage of the power supply. This is a huge deal because it gives you full continuous speed control at literally any point during operation. Inside, it's packed with advanced parts, a rectifier to handle incoming power, a DC bus capacitor to smooth everything out, and an IGBT inverter to deliver that ultra-precise variable frequency directly to the motor. So, how does this build into an actual step-by-step working process for the soft starter? Well, step 1, the power supply comes in. Step 2, those SCRs we just mentioned gradually open up, slowly dripping in more voltage. This gives us step 3. The motor starts smoothly without violently jerking the mechanical parts. Once the motor finally hits full speed, we hit step 4. The bypass contactor clicks on. This literally bypasses the SCRs entirely, sending direct line power straight to the motor for step 5, where it just runs continuously at full speed. It is incredibly efficient for what it does. And this brilliantly illustrates the VFD process, which, is a bit more complex. First, your standard AC supply enters the drive. Second, the rectifier section gets to work converting that AC power into DC power. Third, the DC bus takes that DC voltage and filters and smooths it out. Fourth, and honestly, this is where the magic happens, the inverter section takes that nice, smooth DC and converts it back into a highly controlled variable AC power. Which brings us to step 5, completely variable speed motor output. You have absolute control from 0 all the way to full speed, and sometimes even beyond. Section 3, the ultimate comparison. It's time for the head-to-head clash. When we put them side by side, the contrast is actually pretty stark. Look at speed control. A soft starter offers exactly 0 once it's running, while a VFD gives you full control. Because of that speed control, the VFD has a really high energy saving potential, whereas the soft starter's pretty low in that category. But wait, you have to consider the cost and maintenance. A soft starter is much lower in initial cost and requires very little maintenance. A VFD, on the other hand, is a larger upfront investment and requires medium maintenance just because of its complex electronics. So, the crucial point here is making your choice based on their specific advantages. The soft starter wins hands down on low cost, simply reducing mechanical stress, and being just incredibly easy to install and wire up. It has one job and it does it perfectly. On the flip side, the VFD's advantages are really geared toward the modern, efficient factory. It gives you total speed control, unlocks massive energy savings, especially on things like pumps and fans, and allows for deep process automation and remote monitoring. Section 4. Applications and Selection Guide. Let's talk real-world uses. The sources point out that if your factory really only needs to get a heavy load moving smoothly and then let it run at a fixed speed all day long, the soft starter is your clear winner. Think about massive air compressors, rock crushers in a cement plant, basic water transfer pumps, or heavy conveyor systems. I mean, you don't actually need to vary the speed of a rock crusher while it's crushing rocks, right? You just need to make sure that starting it up doesn't snap a drive belt or crash your factory's electrical grid. But, and this is a big but, when continuous speed control and energy management are required, VFDs are absolutely essential. Take HVAC systems, where airflow literally needs to adjust based on the room temperature, or textile industries, where thread tension requires ultra-precise speed adjustments. They're also crucial for CNC machines, food processing lines, and even smart agriculture using solar pumps, where the motor speed has to adapt dynamically to how much sunlight is available. In those scenarios, a VFD pays for itself in energy savings super quickly. So, boiling this entire selection guide down, it really just comes to one straightforward question. Do you simply need a smooth start to protect your mechanical parts and then it's just going to run at full speed? If yes, the research says choose a soft starter. But if you need to control the speed of the process throughout the day and want to capture energy savings by slowing that motor down, a VFD is 100% the way to go. It really is that simple. Now, what's really interesting about this is seeing these theories actually applied in real industrial case studies. A major textile factory recently overhauled their lines, and they strictly used VFDs because precise speed control means fewer thread breaks and higher quality fabric. Meanwhile, a cement plant installing a massive new rock crusher went with a soft starter. They just needed the raw torque to get that heavy fixed-speed load moving without breaking the shaft. And a recent smart agriculture solar irrigation project, they used VFDs to dynamically manage the pump speeds based on exactly how much sun was hitting their panels. Moving on to Section 5, Common Mistakes and Safety. Okay, we have to talk about mistakes, because the research highlights that getting this wrong carries extremely high costs. Wrong product selection is obvious, but incorrect parameter setting is a huge one. Literally, telling the drive that the motor is a different size than it actually is can burn out your equipment in minutes. Not to mention, poor earthing or grounding creates electrical noise that can completely ruin communication signals across your entire factory floor. And of course, overloading the drive beyond its rated capacity is just a guaranteed way to bring production to a grinding halt. And because we are dealing with serious high voltages and heavy machinery here, the guidelines stress that safety is completely non-negotiable. They mandate implementing lockout-tagout, or LOTO, before you even think about opening a panel. Proper earthing isn't just about reducing noise, it literally saves lives. The sources also emphasize making sure technicians are wearing proper electrical PPE, double-checking cable sizing to prevent electrical fires, and always sticking strictly to the manufacturer guidelines. Cutting corners on the shop floor simply isn't an option. Finally, Section 6, DEVI Automation Solutions. And honestly, this is exactly where industry experts come in, specifically DEVI Automation Solutions. Their whole motto is smart technology, powerful solutions, better tomorrow. Whether your specific application demands the raw, rugged starting power of a soft starter or the precise, energy-saving finesse of a VFD, DEVI has the proven expertise to engineer the absolute perfect solution for your facility. DEVI offers an incredibly comprehensive suite of professional services. We're talking full-scale industrial automation, including PLC, HMI, and SCADA development. They expertly handle VFD and soft starter installations and build custom motor control panels. They are even pushing the envelope with AI, the industrial Internet of Things, smart agriculture, and solar integration. If you found this explainer helpful, definitely be sure to like, share, and subscribe to DEVI Automation Solutions, and reach out to them for your next big project. So, I want to leave you with this final thought. Take a look around your facility. Every single motor humming away right now has a perfect control match, one that maximizes its lifespan and minimizes your energy bill. Are you making the right choice for your factory floor? Well, armed with everything we've covered today, you are now completely ready to make that call. Thank you so much for joining me for this explainer, and as always, stay curious.